JavaScript is everywhere. On the browser, the server, and now on hardware. Finally, the Internet of Things is upon us, and it's powered by JavaScript. Even if you consider yourself a web developer and you have no interest in maker culture, keep your eye on this space, because the hardware, the Internet of Things space, the factories in Shenzhen, they're making better, more modular products, and before you know it, hardware will be as easy and cheap to put together as a web app, and the same supply chain economics that are driving down the cost of smartphones and smart cars will give the masses all the simple components they could ever need. On today's episode, Andrew Chalkley joins us to discuss how JavaScript can be used on hardware. We talk about the players in the hardware space, as well as how the big cloud players like AWS and Azure are positioning themselves to be the data lakes for the Internet of Things. But first, we're going to hear a quick message from the sponsors that make this show possible. You don't have to settle for a job that makes you unhappy, and you don't have to go through the pain of searching through millions of job listings. Hired.com brings job offers to you, the engineer. Hired is a job marketplace built for the engineers. A few years ago, I was unhappy with my engineering job. I felt stuck, I felt underpaid, I felt alone, and I didn't know my value in the job marketplace. It's a very opaque market. So I used Hired.com to find a new position. Hired connected me with a talent advocate who guided me through the process, like a free concierge. They made me feel valued. It was like a white glove service. And this talent advocate helped me with all the questions I had. Should I ask for more money? Should I consider relocating to try to get a higher salary or a better job? The talent advocate that you get paired with on Hired.com helps you with all these kinds of questions. I got several job offers, and I found one that was a good fit. In fact, engineers who use Hired.com get an average of 5 offers from great companies like Facebook, Uber, and Stripe, and the companies are bidding on you to try to get the best engineers, and so you end up with the higher salary. Go to Hired.com/SEDaily for a $4,000 bonus upon signing up. It is completely free to engineers looking for a job. I've interviewed the founder of Hired, Matt Mitchkovich. He also started 99 Designs and SitePoint. He's a software engineer, and he understands that engineers deserve the leverage in this super competitive market where great engineers are at a premium. Check out Hired.com/SEDaily. I'm happy to advocate Hired to my listeners because it puts power in the hands of engineers. Now let's get on with this show. Andrew Chalkley is a JavaScript programmer with a passion for hardware. Andrew, welcome to Software Engineering Daily.
Thanks for having me on.
You write JavaScript for hardware, and a decade ago this would have seemed crazy. Why are we writing JavaScript on hardware these days?
Good question. Generally, there's been a high barrier to entry with hardware. You've got to learn C. You know, when you learn programming, you tend to go on the front-end approach. You learn HTML, CSS, and JavaScript becomes your first real language. And you don't need to worry about a lot of things. Whereas like with C, you need to worry about memory allocation and this, that, and the other, and all the nasty stuff. Whereas with JavaScript, you don't. So I think that's where the desire to write JavaScript, or with other programming languages like Python, come in as well.
So is this like a particularly good does it turn out to be a particularly good language for hardware, or is this just like a bizarre evolutionary outcome where we were writing front-end code in JavaScript, might as well do it on hardware also?
I think the answer is both, this bizarre evolution and an awesome language. So if you think about it, JavaScript, the language, has always had this bad rap, and it's been surrounded by because it's been conflated with the DOM. The JavaScript and the DOM and the DOM APIs, and it's not implemented right in this browser and that browser, and the late 90s, mid 2000s that's what JavaScript got the rap for. But as a programming language, the native objects and the native language API is nice. And so I think as a language, it works, in these multiple environments, as with like Node.js and things like that. So I think it's coming to a point where like you can't avoid it, and there's a lot of hardware vendors who are really putting their resources and investing in getting JavaScript to run performantly on these devices. I was listening to an interview by someone at Konoma, which is a JavaScript hardware company, or it's part of the Marvell hardware company, and he was saying that they were working on a Sony e-reader, and in Japan it was running C, and over in the States they did the operating system and all the things associated with it in JavaScript, and it ran faster in the JavaScript code than it did in programmed in C. Whether if that's because people were more used to writing in a particular way in JavaScript versus C, I don't know. But anecdotally, JavaScript can run better than C on a Sony e-reader.
So there are many different flavors of JavaScript. Does the JavaScript that we write for hardware look distinctly different than JavaScript that we write on other platforms?
Yes and no. Again, it's really an interesting thing. So I've been doing research into the various different hardware types and the JavaScript that runs on them. So let's start off by defining what kind of devices JavaScript can run on. So there's the microcontrollers, which are small, really tiny computers with limited RAM, limited storage space, and you're going to get like a really old version of JavaScript running on there. A modified version of, say, ECMAScript 5 JavaScript. And the tooling surrounding that isn't that modern. It's not that great. I've tried to help with contributing to some of the GitHub repositories, but it's going to take some time for those type of systems to work great. I mentioned Konoma. That's coming out a microcontroller that can run ES6, and it's going to be about $20 and have Wi-Fi built in. So it's evolving to be more modern on that front. The next type of device is like an embedded Linux system. So basically, it's a full-fledged computer. So you can normally they run ARM chips, but there's some Intel ones out there, and you can run full node on there. So you can use all the tools that a modern software developer can use to start writing that hardware. And
yeah, so we'll get into each of those different types of how to do JavaScript on hardware, the JavaScript IoT. But I'd like to motivate the macro discussion a little bit more. We've been hearing about Internet of Things for many years. IoT, we're going to have our refrigerators talking to our coffee maker, talking to our car, talking to our cell phone, talking to our watch. Why is this finally coming to fruition? I mean, obviously we don't have that glory days yet, but we are obviously at the point where a naive software programmer like myself can do things on hardware, and that seems almost preposterous. Why is it that we're able to do this now? Is it just the JavaScript story, or is there like another set of stories, another set of coincidences, like hardware decreasing costs or anything?
Absolutely. So there is this. A few exciting things happened late last year. So an Internet of Things product is something that has either Bluetooth or Wi-Fi built in. Late last year, Arduino released a Arduino 101, and it's got an Intel Curie chip, so it's got Bluetooth built in. Now, that's just fractionally more expensive than an Arduino Uno. which is the starter board for many people. But now it's connected via Bluetooth. So to do an Internet of Thingsy thing is a lot cheaper than it was before. Normally you had to spend like $60, $50 to attach Wi-Fi or Bluetooth to the device. So that's really exciting that this is happening. And then there's the Raspberry Pi Foundation on Thanksgiving announced the Raspberry Pi Zero. Now that's $5 for an embedded 1 gigahertz processor computer. I mean, it's not an Internet of Thing because there's no Ethernet jack or there's no Wi-Fi, but this can be picked up for like $10 for to plug into the USB. So it's getting to a point where like all these devices will have connectivity built in at a low cost. There's another one, another partnership that Arduino did. I think it's called the MK1001 or something like that. It's got Wi-Fi built in, and they're all coming down in price. And I think that connectivity is a must. So, like I said, just coming up this year, there's this Kinoma, which is $20 with Wi-Fi built in with ES6. So this year, I think we're going to see a lot of exciting things. A lot of the things haven't been ironed out yet, but since I've been talking about this stuff, people are really excited. And, every single conference has an IoT like track or people talking about it. So
okay. I understand from that point of view, and it's super interesting that we have these little tiny computers. And I'm curious when we get to the point to where my refrigerator has a hackable API, and I'm curious, like, what are the barriers? Because it seems like putting the computer in the refrigerator is no longer the problem. Now it's the question of how can the refrigerator expose an API to that computer such that I can interface between that computer and the refrigeration aspects of and the monitoring aspects that could take place in the refrigerator. And how can that API work in a way that it can't be, I guess, hacked? Like, is this a security question?
Yeah, there's that, right? A lot of the low-cost devices, say, for example, there's a popular board out there called the ESP8266. It's a Wi-Fi board, and it doesn't have like SSL or anything like that built in, but it's got Wi-Fi and things like that. So it's $2 to pick up from China or like on eBay or something like that. And you can flash JavaScript onto it. You can flash Python onto it. You can do interesting things with this board. The security aspect, is still a thing. There's, like I said, there's another chip coming out this year by the same people who did this ESP8266 that has the security built in. In terms of APIs, I don't think even the hardware vendors, the know IoT is going to be this thing. Like Intel knows it, Atmel knows it, but I don't think they know how yet themselves. And the tooling around it is the issue. From the end user to the end user developer, the tooling isn't there. There's not this ubiquity of these APIs and so forth. Well, we've seen it happen in the browser world where the DOM is standardized, even with all of its quirks across multiple browsers. And I feel that Node.js has an opportunity to be a set of APIs rather than, it's this thing that runs on the V8 engine. We're starting to see that with Chakra Core. You can install Chakra Core with Node on an IoT device running Windows 10, for example. But like, what if those APIs were well documented and, you could pass to a certain degree of certainty, like have a test suite. So whether if you had a simple microcontroller running a JavaScript implementation, a low-level JavaScript implementation with those Node APIs on top, then you've got access to all these developers who do JavaScript and Node. So it doesn't really matter whether if it's a microcontroller or an embedded Linux system. We just know that it implements the Node APIs. And that's what I would like to see as a developer. And I think that's why the web is such this amazing platform, is that you know that the set and JavaScript APIs are well implemented now, and that you can deploy this piece of software across many devices and many desktops. I think the same needs to happen in the IoT world.
Okay, so let's get into this discussion of the three main strategies for JavaScript IoT. I've heard you discuss these. So before we get into them individually, what are these three different strategies for doing JavaScript Internet of Things programming? Okay,
so there's microcontrollers, embedded Linux systems, and then like a hybrid of that, or the client host model.
Okay, and what is the definition of a JavaScript-only microcontroller?
Okay, so on the device itself, it will just have like a JavaScript runtime running on it, nothing else really. So it's very low level, highly optimized. It can do quick input-outputs to sensors and things like that.
And you have the most experience with the Espruino Espruino Pico. So
Espruino Pico.
Tell me about that. What do you like about the Espruino Pico? Pico, Jesus. I've even been studying Spanish lately, and I'm just totally failing.
Yeah, so the Espruino Pico was a Kickstarter project. I backed it. I got the first one in, and it's really tiny and embeddable, which is great. It's the Espruino JavaScript runtime can be installed on other devices as well, which is interesting. But so I like it because it's really tiny. It can be embedded in things. But, you've got to do a lot of soldering, which, coming from a software background, soldering in America is really intimidating and scary.
Okay, yeah, so I am a software engineer also. I know nothing about soldering. Why do I have to do that?
Well, so this Pico comes with little holes in it where you can attach wires for sensors that talk to the chip on the device. And in order to get to it, you could maybe try and use crocodile clips and not do anything like that. But then if you're trying to embed it into something, you really need something more solid, like soldering. So soldering is a way to make a chemical bond between a wire and the board through these little holes in it, sort of thing. So, I've done a few butcher jobs in the past, and I'm not that great still.
So can you give me an idea of like something that you've built with the Espruino Pico?
So I built a thing called Wi-Fi Gotchi. So it's like a Tamagotchi connected to the internet. Right now, it's just a basic example where it shows a face. Well, it doesn't have a face if it's not connected to the internet. Once it tries to connect to the internet, it hits an API pun on wi-fi.gotcha.com. So if any of the listeners want to change the mood of this virtual pet, you can go there and click on one of 3 emojis to change its expression.
That is a great minimum viable product, by the way.
Yeah. Because I was thinking, I could give it food or like pet it. It's like, no, 3 emojis, click on one of them and see how it goes.
Okay, and one of the interesting things that I've heard you say about Espruino, the Espruino platform, is that there's a web IDE, and even today, a lot of programming is not a lot of IDE work is not on the web. So the browser IDE is this really appealing feature. So it sounds pretty awesome. Can you tell me about the web IDE and what is it like to program for the Espruino Pico on the web IDE?
So it's a Chrome extension. You install it and download it, so you don't need to necessarily worry about, I need to send this to a COM port or a serial. Like, what are those things? A web developer doesn't really come into contact with that, really. So you can basically push your code straight to the app, the device, and it really only supports one file at the moment. There are hacks that I got around. And it's in beta right now where you can use npm packages. So I created an npm package, for example, which was one workaround. Instead of having lots of code to drive a display in a single file, I just require it. So that it doesn't have like the package.json that JavaScript developers would understand. But if you're just starting out and tinkering with it, that it may work well for you. I know they've got a Blockly interface as well in this web IDE. The disconnect that I see between the web IDE and the actual device itself, it feels like you've got to be a lot more physically hands-on and do all this soldering to get sensors, but the IDE is supposed to be for a learning experience. So it feels to me there's a slight disconnect there where, like, if it was just, say, for example, the Arduino has these headers where you can just stick things into, and that's slightly easier to prototype on. Whereas the Pico and the Espruino, the full board, requires a lot of manual soldering and stuff like that, which I don't think is beginner friendly as, they're expecting it to be, having this web IDE.
Okay. Cloudinary is the image backend for web and mobile development. As web and mobile development have become more about images, you might have found yourself frustrated, manipulating images, uploading images, trying to optimize their delivery in your website or in your mobile app. Cloudinary makes software development with images simple by combining the speed of a CDN with an API for tasks such as image manipulation, uploading, storing, facial recognition, and of course, fast delivery for any device. Software Engineering Daily loves showcasing products like Cloudinary because it is so focused. It provides a great experience both for developers and the end users of those developers' products. You can try Cloudinary's image manipulation easily by going to cloudinary.com. You can upload an image of a cat, for example, and resize it by simply changing the URL. Now that is a rich image API. Cloudinary is used by companies like Dropbox, Gizmodo, Fiverr, eBay, Lifehacker, many more. These companies obviously have tons of images and high demand for how they want to manipulate and serve their images. Cloudinary is also a proud sponsor of O'Reilly's 2016 Fluent Conference, which is March 8th through 10th in San Francisco. And Software Engineering Daily is giving away a free ticket to Fluent. To be entered into a drawing for this ticket, tweet at software_daily about your favorite episode or tell us why you love Cloudinary. Thanks again to Cloudinary. We are proud to have you as our newest sponsor. So let's move on to talking about the next strategy of JavaScript Internet of Things programming, which is embedded Linux devices like the Tessel 2 or the Raspberry Pi. Why is this strategy appealing?
So, yeah, you can use your own modern tool framework for this. So, like, you can use NPM, you can install versions of Node that will run on these devices. I believe Node Source has all the binaries for the different ARM chips that are in these embedded systems. So, you don't need to install anything extra that you wouldn't normally install on your system. You can use your own IDE like WebStorm, or you can use Visual Studio Code and just used to the tools that you want to use. There's a lot of room there for improvement for interfacing with the device itself. So, say, for example, there's a lot in the maker movement. There's a lot of focus on just creating projects. Hey, I did this in my house. Hey, I did this thing. And it's like, okay, so you follow this tutorial and you mash all this stuff together and yeah, it's done. And who knows how secure it is, and who knows if you took that out of your house and put it into someone else's house, would it connect to the Wi-Fi there? Things like that. I think there's like a gap. And because we're talking about the Node.js level of things, I think a lot as developers in the Node.js community, we can really start contributing to this. So I've started like developing a toolkit for developers that can I I don't know if you've seen this, but like on many of the Hacker News articles, hey, I created a smart mirror.
Yeah,
and
show HN.
Yeah. So a smart mirror is where you have a monitor screen, a 1080p monitor screen behind two-sided glass and two-sided mirror. Sorry, and when you shine a light through a two-sided mirror, it appears on the mirror itself. So what people do is they have a black screen and just have white text pop up. So that's a smart mirror.
Yeah.
So I want to make one of these things, but I want to use like modern tools like Node and all this sort of stuff. But it's like it feels to me like, yeah, it'd be cool to put that in my house. I manually SSH'd onto it and typed in my Wi-Fi and all that. But that isn't really good as a product or like for usability for me as an end user, right?
No,
Like,
it's terrible.
If I wanted to go to a meetup or a conference and say, hey, I built this smart mirror using Node.js, wait a minute while I SSH onto this thing and configure the Wi-Fi, it isn't a good approach. So I think
it's a worse user experience than the non-smart mirror.
Exactly. So there's these tools that are missing, and I've identified like 3, possibly 2, maybe 3. I'll see when I'm talking about how many there are. But the like a Wi-Fi scanner, like finding the local Wi-Fi hotspots nearby. If you can get that programmatically, you can show that in a list to say, hey, I want to connect to this thing. Then there's a Wi-Fi manager, so it manages that hotspot when it connects to different hotspots, and it can spawn a hotspot, for example. So, like, imagine you take your mirror to a new place, it can't find your local network that you were on before. It says, okay, I'm going to spawn a Wi-Fi hotspot. And then the third thing is a captive portal. So I don't know whether if you've been to a hotel or McDonald's or wherever, you connect to the Wi-Fi and boom, this thing appears on your screen. That's called a captive portal, so that you can, give your details, agree to the terms and services. But in
do
this
online
case,
banking.
Do online banking. At McDonald's, hey, I want a Big Mac, but I just need to transfer some money out my savings. So this captive portal is this thing that needs to be there for products, right? So like, this smart mirror is taken to a conference. It says, hey, connect to this Wi-Fi hotspot. It displays a list on your mobile phone of all the Wi-Fi hotspots when you've connected to it, and say, oh, yeah, I want to configure that. So there's, I believe, the 3 core parts that are really missing everywhere. Whenever you look at, like, hey, this is how you control this chip with Wi-Fi, it's always like this callback pyramid of doom, and it's like only specifically used for one instance. Now, my Pico project, I've started trying to figure out a pattern of how to architect that type of connectivity, and I want to have this common set of like APIs that would work on these devices, when connecting to Wi-Fi, and like that pattern. I think the mobile app industry have got certain, patterns that you typically don't use with Node.js. With Node.js on the server side, you'd say, hey, I'm always connected, I'm always connected to the internet. I don't need to set the network interface up and down and, all these things. You just accept that they're connected. So Node.js in this environment is this new thing, and there needs to be some new APIs and patterns. And maybe we can look to the offline modes of apps, on Android and iOS for inspiration.
Okay. And speaking about these different types of embedded Linux devices, we had Kelsey Braceman from Tessel come on the show just as an example for how these devices are evolving. How did the Tessel 1 compare to the newer Tessel 2, and how do these different maybe you could draw a comparison to another embedded Linux device. How do these different ones compare? What are the different models?
Okay, so the Tessel 1 was a microcontroller that actually ran Lua on it. So that's the ESP8266 runs Lua too. But what the Tesla crew did, they created a transpiler and transpiled many of the Node APIs into Lua, so it ran on the device. The Tesla one was analogous to the Espruino, but running Lua. And then just recently, I believe mine is being shipped to me right now. The Tesla 2 is an embedded Linux system. It's built on the same kind of chipset that's in your router. And those routers can run Linux. They all run a modified version of embedded Linux. And they've done that with the Tesla 2, so you can plug in USB devices. Because the Tesla was great because you don't need to solder things so much. You can just plug things straight in. The unfortunate thing is, like, if you want a Wi-Fi card in this what's the word? Unstandardized, not standard. It's not standard. If you want to get a Wi-Fi card that's not standard for this Tesla, it would be like $50, and the device itself is like $60. It's like, why am I doing this? Like, I've spent $100 on this thing. Whereas, like, with the Tesla 2, you can plug a USB. Well, I mean, it's got Wi-Fi built in, but like, if you were to embed Bluetooth or some other like USB technology, like a camera or something like that, the Linux driver should handle that for you. They're relatively cheap to pick up, these USB devices, but it still has this plug and play ability for sensors as well. So the Tesla 2, because it's embedded Linux, like the Raspberry Pi or the BeagleBone, it has more opportunity to run full node software and have that USB connectivity. Okay.
Speaking of price, we should talk about the Raspberry Pi Zero, which is, as you said, a $5 computer, but it is not an internet-connected thing.
Right.
Okay, what does this mean? Like, not an internet-connected thing. Does this mean, what is the I/O interface? Do I use Ethernet, or is it USB? Or how am I connecting to this thing if it's not internet-connected?
Okay, so I managed to get a hold of these things. They're like gold dust right now. So if you were to try and buy one on, say, eBay, they'll be like $30 or something like that. But I got a hold of one, and there's a couple of ports on the thing. So there's the power port, which is like a micro USB. There's a USB on the go, which is like a micro USB port, which is used for if you're charging your Android devices or things like that. And then there's a mini HDMI connector. So the only way you can connect to it on a network is by plugging into the USB on the go. So whether if that's through a USB hub, or you can get these small adapters that fit into a regular size USB port, and then it goes into the micro USB port. That's how you get it connected. So Apple took out Ethernet ports a long time ago from their devices, but they've got built-in Wi-Fi. But I had one of these USB Ethernet things hanging around from that, and I was able to SSH onto the thing and do stuff with it. But if you hook up a keyboard and a mouse and an HDMI to mini HDMI, you can actually work on the device itself. It's not connected. So you'll see this project like embedded into like game controllers with emulators on, or maybe the brains of another robot or something like that, because it's really tiny. It's like half the size of a Raspberry Pi, which is the size of a credit card. So it's half the size of a credit card. It's got a very low profile because it doesn't have 4 USB ports on it or an Ethernet jack. So I really wish that the Raspberry Pi Foundation, if you're listening to this, would bring out a Raspberry Pi Zero Plus with like a Broadcom wireless chip in it. So like maybe $10 or $15 for the whole package. That would be awesome. That would absolutely make this Internet of Things a real thing.
Raspberry Pi 0.3 or 0.2, whatever.
Yeah.
So the third strategy that we have not discussed yet is the hybrid solution. So what is a hybrid solution and why is it useful?
Yeah, so I've called it the hybrid solution. There's another name for it, the client host or host client model, where you have a microcontroller that doesn't run JavaScript. You put a client on there. It's a special firmware which is like a dumb client, and then you talk over a particular protocol with JavaScript or whatever language you want. So if you're a Rubyist, if you're using Java or something else like that, you can use it too. But the most commonly used one in the JavaScript world is Johnny 5 and the Silent.js. And they talk to an Arduino, which is a microcontroller that normally runs C, but it's got a special firmware installed on it. So your computer that's running full node or a Raspberry Pi that's running full node can talk over USB or Bluetooth to one of these devices and get that high input-output because it's really low level. So, say, for example, if you did have a robot, you may have one Arduino controlling one arm and fingers and another Arduino controlling one arm and the other fingers, and then the brain of it may be a Raspberry Pi or your laptop beside it or something like that. So that's so the host is like the full-fledged computer. The client is the Arduino or the Arduino compatible boards that can run this firmware.
I would like to get a better idea of the interfaces that we are using to speak in JavaScript between devices. So JavaScript can be used to read from a variety of sensors. Like, what are some examples of these sensor types, and what is the interface between these sensors? Like, what is the communication layer between the sensors and whatever JavaScript platform you're using?
Yeah, so in terms of Johnny 5 and things like that, you can practically communicate with any sensor. So once you get the fundamentals of like communicating with one sensor, it's just like on and off. You know, there's a signal coming in, from it and things like that. So once you've got the basics of sensors down, you can use Johnny 5 and all these other things to communicate with callbacks or what have you, and things like that. So the firmware is called Fermata. I think that's how you say it out loud. The Fermata firmware, and the protocol is abstracted away from you as a developer. You don't need to really know it, right? So there's a Fermata driver in every single language under the sun. Johnny 5 is yet another abstraction on top of that. So you just, the documentation is is great there, and you just follow the samples basically. So yeah, a lot of this stuff on the Johnny 5 node side is there for you already. You don't need to worry about it. Whereas with the Espruino Pico, I naively got this thing. Oh, it's been around a year or so, thinking that there's an online store and tutorial site called Adafruit, and they're well known in the maker industry, and they provide different types of boards. So, say for example, for my Wi-Fi Gotchi, I got an output, which is an LED matrix, an 8x8 screen. And I thought that this thing would have a driver already, or it'd be trivial to interface with. Now, I had to learn... I understood binary, it's base 2 counting and all that, but I had to learn it in the context of JavaScript to get this thing running. But I've wrote a driver for this display, so no one else has to do that.
Oh man! But, wait. So to clarify, you had to do some crazy deserialization stuff.
It was bit shifting and all this stuff. Like,
oh my gosh.
I'm not a computer scientist. I'm a programmer, right? I'm self-taught. I understand that there's ones and zeros, everywhere in the computer, but it's, I deal with a higher level of abstraction in my day-to-day, like, coding life, and but it wasn't too difficult. The Esprino forum, I posted a question in there, I got an answer. I posted a question to someone on Twitter, from Adafruit, and they says, oh, it's wired this way because of reasons. And it's like, okay, so I'm kind of getting the vocabulary I need now to ask this question. And then once I was able to ask the question and parse that information out, I was able to create this library so other people can enjoy it. So going back to the sensors, like there's a standard that people use where they can be plugged into a breadboard. Now, a breadboard is this, I don't know, a couple of inches by, 5 or 6 inches, boards with little holes in. And basically in those holes, at the bottom, there's like channels where electricity or signals from the sensors can go down. The reason why it's called breadboard is because back in the day in electronics, people had to like nails into a breadboard and then hook the wires around this breadboard. So that name stuck, and you hook up wires and you connect sensors to it. So generally, things that are breadboard friendly are really good for prototyping because you can just plug them into the breadboard and then plug them up to your Arduino, in the case of using something like Johnny 5 or a Raspberry Pi. Or like, for example, for a Esprino, you'd need to solder on the headers, they're called, that you plug into the breadboard to do your prototyping.
Okay, and how much do these things cost? Like if I want to get a temperature sensor that plugs into a breadboard, how much would that be?
It depends how savvy you are, right? Like, you could get like a big kit from, Adafruit So the devices themselves can range from like a couple of cents to like a couple of dollars. The more complex the devices, like a breadboard-enabled Wi-Fi board, maybe like $20 or maybe $50, depending on what time of year it is and like how ancient the technology is. But even still, is still quite expensive. You can go to places like AliExpress, which is Alibaba's end user foray onto the web. You can go on there and you can pick up sensor kits for relatively cheap, and they're delivered free anywhere around the world if you're willing to wait a couple of weeks. So there's a wide variety. Like, say if you wanted to buy a speaker, that's a tiny speaker, it's about $170 to pick up. I accidentally bought 10 once, so I've got to use all these things. But you may need an amp to increase the signal from the device itself, and that costs $250. So it can all spiral out of control pretty quickly with this stuff. Yeah, you're not just investing your time, but you're going to invest your cold hard cash, and you're going to make mistakes. I've made mistakes. When I was soldering my first Esprino board with a Wi-Fi shield, or a Wi-Fi shim, it took me forever to do, and I missed a particular step, and I couldn't desolder it very well, and I thought,
there's no Control Z in soldering.
Yeah, there is, but I'm not skilled enough to do it.
Oh, okay.
So there's this wick that you can do, but this Esprino Pico, there's really, really tiny things on it, and you've got to get the right heat and pull away at the right time. And I thought, this is wasting more time of me doing this than me actually, going out and buying a new one and waiting for it to come back to me. I could still prototype on the board for other reasons, but I couldn't necessarily get the Wi-Fi going. And for example, all the debugging skills that you've got from software development, sometimes you just say, maybe this will work, and it does work in software, and it's like, oh wow, cool, this really works. Like, say for example, when I got my second Esprino and the Wi-Fi shield, it was the connectivity, the solder wasn't that great on one of the joints, but I couldn't get in at it. So I got a wire and just put it in a hole until the Wi-Fi connected. And it connected on this one, so I soldered that wire in. I don't know why it did it, but it worked. Those debugging skills that you've had in the software world can translate in weird ways in the real world in hardware. So
interesting. Yeah. Okay, well, I want to talk some more about the bigger picture. And one thing with software. So I had a conversation recently with the organizer of the React JS conf, Brent Votny, and he mentioned this React library for dealing with hardware. And I'm curious if you've used this, and I'm also curious just if there's any, if it seems like there's some like really de facto, easy to use software libraries that are being built up, because JavaScript, when I think about JavaScript and the Internet of Things, that sounds so raw at this point. It sounds like such a raw way of programming, and it sounds like we're not yet at the place where we have the fantastic interfaces, the fantastic software abstractions that we need. So give me a picture of the software libraries that we are using to program JavaScript hardware.
Okay, so there's so for the microcontrollers, for example, like the Espruino, there's a set of standard modules that the Espruino folks maintain, and you can contribute that. And if it's in their GitHub repository, it will be included on the device if you do the require for that particular module. Like I said, that they've got a beta right now where you can, if you do a flag in the web IDE, it will install npm modules from the wild. So instead of me jumping through all these hoops and committing to the central repository on their thing, on the Espruino thing, I thought, hey, I'm a web developer. This npm is becoming this massive repository for jQuery plugins and everything else under the sun. Let's do it for this. So, like, I named it like Espruino Adafruit LED backpack or something like that. So, okay, it's for the Espruino. It's an it's an Adafruit LED backpack. So that kind of thing is the naming convention that I've decided, right? Because it's obvious that it's for the Espruino. It's from Adafruit and what it is, right? So it runs a driver for that. And the tooling for that, I found like publishing an NPM module myself was a lot more easier than jumping through the hoops of having it in their standard library. There was just friction there. And if people like me who are web developers by day or night want to like engage in this community, there's so many valuable lessons they can learn from you, like by just publishing software packages like that. And if this is a significant amount, like I've got no idea how many Espruino packages there are on there. I know there's a few command line tools, so if you wanted to not use the web IDE, you can use your own. But there's limited support for that. So in the microcontroller world, it's really difficult. I've got no idea with the Kinoma, which has a more expensive screen-based one right now. I haven't played around with that, but that's coming out, later on this year. This non-screen based one, and I want to try that out. I'm basically researching everything and seeing where they're not making sense. For the embedded Linux systems, it's all npm. You can install Johnny 5, or wiring JS to, which is another way for talking to the GPIO, which means general purpose input output. The headers that looks, if you've ever had an old computer, it looks like an IDE cable for hard drive, but it's not. It's input output for sensors and things like that. And there are people that have just published even their first npm package just for hardware purposes, and things like that. I know Adafruit have done a lot of work porting a lot of their libraries to Python, so they've invested in that. But when I did my driver for the Espruino, I mimicked the APIs that the Adafruit Arduino library did, because I thought if you're familiar with Adafruit's Arduino library, you should be familiar with it in JavaScript. It's maybe just slightly different, but you should be able to do it.
Okay, so zooming out even further, like I no, it's totally fine. I want to talk about the cloud platforms that will run the Internet of Things as we are spinning up the Internet of Things. We've got AWS and Azure with their armies of software engineers working on their respective platforms. And there's plenty of other companies that are trying to own the Internet of Things cloud space. What's your perspective on this? How is this going to evolve over time? Obviously, if you've got, a bunch of sensors reading into your Internet of Things hookup, that's a lot of data. That's a lot of data to be stored. That's a lot of money for these companies. How should you invest, in these different platforms?
That's a really, really good question, because, the skeptical side of me is like, oh my goodness, these centralized places want our information. They're on servers where governments and this, that, and the other can get at your data. If you're paying for the service, I think as a company, you're at a better advantage. But why are you as a company storing that data? Like this comes into like the digital bill of rights for the Internet of Things. I don't know if you've heard about that, but there's certain things like the person's data is their own data, for example. Like if you subscribe to that philosophy, then if they want it deleted, they can delete it. Do you know what I mean? But so there's all these different competing platforms, like you say, Amazon Web Services, there's Azure, there's Adafruit, who are now doing their own IoT dashboards. So if you're creating projects yourself, you can do that. But I believe where Microsoft and AWS are coming from, if you are this company and you're building IoT things, we want to store that data. And they want to make it as easy as possible. When I say easy as possible, it feels like a lot of their stuff is enterprise grade, or enterprise ready for people who understand, the C# and the Microsoft world. For me as a, primarily open stack, type of guy.
No, I think it's actually a little more open. I just did a couple shows with Microsoft on their Azure platform, and it is quite open. The APIs are quite open. It sounds like their way of viewing things is just that there's so much to do, and what these companies would like to do is the trade-off that you're making is you store your data in AWS or Azure, and perhaps you will pay a higher price than if you store it on, let's say, a DigitalOcean or somebody who has less rich APIs, less enterprisey APIs. But in exchange for that, the richness of the APIs are the level that you would expect from a really robust, open source platform. Just the that feeling where you interact with a higher level API for the first time, you interact with a Ruby on Rails for the first time, and you're like, oh, it's just so easy to do this thing that was a huge pain point. This data ingestion of all the sensor data is made legitimately easy. Not like if you fit into this box of C#, then you can do it. It's more like you can do it regardless. And anyway, at least that's the interpretation I got from Azure.
Yeah, and I think that's probably true. I've done a lot of backpedaling on Microsoft. I use Visual Studio Code. I like what they're doing with TypeScript and things like that. But I still don't know what everybody's end game is, right? I don't understand. Do they just want do they want hobbyists to use these things? It feels like they do, right? They're running competitions to say, hey, use Windows Core IoT and we'll give you a free Raspberry Pi or a free Arduino or something. And like Intel themselves, they've got the Intel Curie chip in an Arduino now, and it's like, it's slightly more. Like, what is their end game? Like, do they need the maker movement to do something to the bottom line, or is it they want the Curie chips in everything, or something like that, or to use Azure for everything? Like, I don't know what their end game is, because like there is a reason why they're spending marketing dollars or like just reaching out or experimenting with these things. And but like I was saying, Intel came up to me after giving one of my talks on IoT. Oh, you don't have an Intel Edison? And it's, well, they're expensive. They're like, if you give me one, I'll play around with it. You know what I mean? I've already got like 2 or 3 Raspberry Pis, a blah, blah, and a blah, blah, and blah, blah, and they're all cheaper than an Edison, right? So, what I don't think Intel, or maybe Atmel to some degree, understand, these are the chip manufacturers, right? They don't understand that Arduino, for the last 8 years, have made the most awesome SDK for them for C, for their devices. They should be, if they want this explosion of IoT devices to happen, instead of spending $20 for like a very low-powered, high-throughput IO microcontroller, they should be subsidizing that. If they want like people to learn about it, use it, and not be worried about like damaging things, and that will, allow these inventors and all these new ideas to come in and these platforms to evolve quicker. I don't know if Johnny 5 works with a Arduino 101. I've got one in my basement, but I'm going to have to look at it. But like, that's time and research and goodness of my own heart, that I would need to do that,
Right.
And there's a financial element to this now. It's not just software anymore.
Yeah, well, as far as the end game, I imagine that, these companies have some idea of what their end game might look like, but probably they want to keep things at least a little loose, because I feel like the industry still doesn't really know when the Internet of Things will stop being I feel like we've been being told about the Internet of Things that it's just 2 years away for 10 years. So anyway, well,
it feels like the cloud was like that for a long time. Like, hey, cloud.
Oh yeah.
Yeah. Now it's kind of like stabilized. There's like, there's Amazon Web Services.
Do you ever read
blah, blah, blah.
about these, like the cloud businesses, or maybe you're around that? I don't know how long you've been in the industry, but like in the 90s, like there were cloud-ish businesses that just didn't work.
right and but that's the thing, like I feel because I've been tinkering with electronics since 2013, and it feels to me that the maker movement is like the computer industry, like when there was Apple IIs,
the homebrew club,
the homebrew club and all that jazz. And I feel like, goodness, like the Arduino's been around 8 years, or the Raspberry Pi has been around for quite some time now as well, and they're just like the gradual evolution of these devices. So there was the first Raspberry Pi, which had 256 meg of RAM. That soon changed to 512, and then this evolved the board to be this standard square layout with mountain holes, and then the use the same design but up the power. So there's a standardization that's happening, and it's evolved over time. And it feels like, with the Raspberry Pi, everything's up in the air for you to choose what you want to run on it. You can run PHP, Java, anything that you want. So whereas the Arduino has evolved as a software platform and has matured with their tooling. And for us as JavaScript developers, we need to mature our tools in the context. I mean, we've got mature tools now, and I think we're getting there past the fatigue in the JavaScript world, hopefully, fingers crossed. And we just need to have those mature ideas start to evolve in the embedded Linux systems.
Okay, so I want to close off with a question about your work. You work at Treehouse, which is the online education company. We had Ryan Carson, the CEO of Treehouse, on the show, and that was a really fascinating interview. Ryan's a really, really great guy to talk to. Does Treehouse have plans or a curriculum in place already to do some Internet of Things education?
No. I think there's a number of reasons. I think we're all betting that the software that we teach, JavaScript, Ruby, Java, and so forth, will be available on these things devices, right? Hardware is becoming software, and we teach people how to develop software.
What if there's a paradigm shift? Like today, we just have MVC, we have Flux. These are our web paradigms. But what if there is a specific JavaScript architectural pattern you have to learn in order to program the software on these hardware devices?
Well, you said it yourself. There's this guy using React, to control boards, and if that's the case, well, we'll be developing more React content anyway. I mean, that's the whole thing with React Native, right? It's like you learn React, so you do these components, blah, but you're done, and it's similar with that. Or like, say for example, reactive extensions. That's an awesome a set of tools that you can use for streaming events, in the DOM, in the server side. And guess what? Input outputs on electrical devices. So, the lessons that we're learning at the front end and on the server side are applicable to hardware. I don't think that anything's going to arise out of hardware that we haven't thought of yet. I think it'll be migrating those paradigms onto those devices. Just like that example I told you. So, like, if I encourage anyone who understands software to any degree to start building those libraries and publishing them on NPM, and tweet me and let me know what you've just done, because that's an awesome thing, that you've done. And you don't need to be an electronic engineer. I'm not an electronic engineer. I'm not a computer scientist. I have no degree, and I've done all these things and as well, so you can do it too.
Okay, well, that's a great place to close off. Andrew Chalkley, thank you for coming on to Software Engineering Daily. Fascinating interview. Great to talk to you about IoT, and I will see you at the Fluent conference, which we did not even mention in this show, but your talk will obviously be about JavaScript and the Internet of Things, and I look forward to seeing you there. I'll have a t-shirt for you.
Oh, thank you very much. See you then.